Okay, guys. Today I have come again um, to do one or two experiments, especially based on generator. Mostly my experiments usually about generator. I have done a lot of experiments on generator, and if you are following me a while, you have we you have already gathered one or two knowledge from my what I'm teaching from my experiments. And I have to do my experiments one after the other. Um, so if you're a newcomer, if you're a new follower, kindly go to my video and watch it. So you will learn one or two things from it. I have done a lot of experiments. I have done a lot of teaching, especially on generator, including motor, DC motor. So some of the experiments is what I discovered recently. Some my old discovery. So what you have to do is to pay attention. If there is what you don't understand, you can ask me maybe in the comment section. Then if what I understand and what I know, I will answer you. So we are here to learn. My channel is for learning. So kindly subscribe if you haven't done. Kindly share my video if you find it interesting. So today you can see this is a 1900 generator. This is 1800 generator. Normally they are the same capacity, but working principle, there are difference in working a principle, yeah, working process, there are difference, but the same in capacity. Okay, so here this is AVR. uh AVR stand for automatic voltage regulator. So I will keep it aside now. I want to so if we this is my generator. This is my one of my old experiments uh, I did some times ago. So if you check here, I dig, I file the amateur laminated stator iron. So I place magnet, I place neodymium magnet. So if you check, if you put it on generator and roll it, there will be a current. You see, it is north and south. This repel, this attract. This one repel, this attract. So you can see it is pushing the magnet away. It is pushing the magnet away because north and north doesn't attract, south and south doesn't attract. So it is pushing the magnet away. You see the magnet is turning. So now, but this way, it is attracting. It is attracting. Understand? It is attracting. It is attracting the magnet. So, but this way now, it won't attract. It will be repelling. So it is shifting my hand. So it is repelling. It is a like pole. So like pole doesn't attract. So, but like how my subscriber has suggested, my follower has suggested that I should make it a permanent magnet. Making the armature permanent magnet has some benefits and it has the advantage and disadvantages. So, so I'm gonna talk about it. So, making this armature permanent magnet, one of the advantages is that you won't need much speed to generate current. You won't need much speed to generate current output. Any movement turning the shaft will give you current, depending on the voltage and the current. Uh, the current and voltage, the voltage depend on the turns of the stator winding, while the current depend on the size of the wire and the magnetism, how strong the magnetism is about the permanent magnet. So, but the one of the big disadvantage is that to controlling the current is very complicated. Assuming you have a prime mover which the speed is constant, how will you control the voltage? So it's very, very complicated. But electromagnetic, you can increase and decrease the magnetic strength, whereby if it is a capacitor, you can use a smaller capacitor. It will have a less induction in the rotor. It will have a low voltage. Then, if it is capacitor, it will already censored. So which it will done the whole process by itself because it is already programmed. It's electronics program. So, but if it is a permanent magnet, how will you do that? Assuming the prime mover is constant RPM. So, do you see one of the big challenge in using complete permanent magnet generator? So that's why in most cases, like when to buying generator and a lot of a low RPM generator, they use a lot of components like controller to control the voltage that recharge the battery. But assuming you are extracting the power direct, so how will you manage to maintain the output? So that is the very disadvantage because the strength is already permanent. There is no increase, there is no decrease. Rather, it will be decrease when it meets a high temperature. So I believe I have cleared the doubt. For those asking, the best is to use a permanent magnet. Yeah, permanent magnet has its own advantage and disadvantages also, especially controlling the current because the strength of the magnetism is permanent. So, but electromagnetic, you can increase it and decrease it depending on the time and the mode you want it to operate. So, like I have displayed this before, I modified this and machine it. This is a generator shaft. This is generator shaft. So it was machined by a late machine. Then very very simple when you put it at the range of the stator. Once you cover it, then we rock here. It will stay permanent. It will stay permanent. So that's how it will be rotating. That's how it will be rotating. So I set my magnet this way. But later on, I realized that pressing needle magnet on aluminum weaken the strength. It weaken the strength. So it's better you press needle magnet on iron. Iron shelled it. Iron shelled needle magnet. Placing needle magnet on aluminum weaken the strength. So when I later did it, I realized that using aluminum will decrease the efficiency of the magnet. So it's better you place the needle magnet on plastic than placing it on on aluminum. So that is what I realized. So this is my previous experiment. So most of what reason why I'm showing you what I have did, that the one that work and the one that didn't work, is for you to avoid the wasting materials and wasting resources and time. So that's why this machinery is for you. So I think I have cleared the doubts and the question. So now let me come to the basic point here. This two generator is the same capacity, but they work different. Uh, Here they are the same capacity, but different working mode. This one operates with AVR. This one operates with capacitor. This one operates with capacitor. So now let me pull it off. You can see. So they just wind it. The both terminal they use a commutator. So there have to be a signal. So once you put a current here, it have to be a DC, filter DC, pure DC. Then this laminated iron will turn to electromagnetic. When you decrease the power here, the electromagnetic here will reduce. When you increase the power here, the electromagnetic will increase. So you can see it. Okay. So now this is let me shift it. Let me shift it here. So now this is a induction generator. There is no brush here. There is no commutator here. So they just wind it. They just wind clockwise, anti-clockwise. Then they attach it to diode here. If you check here, this is a table diode. This is a diode here. So because when current flow here, this diode will allow current to pass only one direction by converting the whole system to DC. So do you see it? So this will form electromagnetic. When this diode gets burnt, there will not be any current output. You can see this armature, this rotor or this armature, you will see diode. You will see diode inside it. But this rotor here, there's no any diode. There's no diode. So you can see commutator that sends power to this the winding. So for this rotor, there is a diode. There is no any commutator. There's no any contact. So some people normally call it brushless. This one brush. So now you can see the size. So it has a 6 terminal. The yellow wire is for capacitor. The red and black is for the main 220, 230 volts. Then this green wire is for charging, battery charging. So okay, now the same capacity like I said previously. Um, this generator now, the difference is this one. If you run this one on 1000 rpm, expect nothing, expect no voltage, expect no current, because it has to reach like about 2500. It has to start it depending on the how they wind it and how the generator is. It has to reach something about 3000 rpm or 2500 rpm before it will start. It will create a electromagnetism. There will be a form of electromagnetism depending on the capacitor, the value of the capacitor. Before it will send the signal here, the whole stator will form electromagnetic. Then this rotor here will form electromagnetic before there will be output here. So this thing uh, take faster process. Just drinking of ice, it has already happened, but this is a gradual process it take. This generator, if you are running it on 1000 rpm, there will not be any signal, there will not be any volt. But this generator here, if you run it on 1000 rpm, so far this armature is turning and it has already generated some amount of voltage. It will send it to this exciter, and once it send it to this exciter, this AVR will store it and send it to this commutator here. This whole system will form electromagnetic. So now let me come to AVR. I'm taking it one after the other. I haven't done with this generator yet. You see this AVR. Um, some people don't know much about this AVR, but it's just very very simple if you understand it. This AVR, this is where you can increase the voltage of your generator. Assuming your generator is running on maybe 2000 rpm and your generator you are having about 200 voltage, and you don't want to increase the voltage by rotating the speed. You can increase this potentiometer. You can just increase it, push it clockwise, gradual. By increasing it, it's like you are authorizing this AVR to increase the voltage. When you are increasing it, this potentiometer, this AVR will release some amount of voltage. It will enable or open some amount of voltage that will flow from this terminal to the rotor to the armature. It will send power here. Assuming what the AVR is giving this armature here is 20 volts, and you are generating 200 voltage from the armature. When you increase it to 25 volt here, when you increase it, it will send 25 volt here, and we have maybe 210 or 220 depending on the speed. So it's like here is like authorized. When you increase it, this generator, this AVR, this AVR will increase. It's like you have authorized it. So now, if you want to have a 110 volts, this is when you are increasing with decreasing, turning it clockwise, anti-clockwise. You are decreasing the amount of voltage going to this AVR, and by then the voltage will be going down. Despite that, the speed will be constant. If the speed is constant, you can decrease the voltage by decreasing the voltage. When you are turning it clockwise, anti-clockwise, you are reducing the amount of voltage going to this armature. So now, if you check here, this is the input that goes to the armature. You can see this is how it's attached. And if you are attaching it, be very careful. If you check very here, you will see the polarity sign. This is a plus sign. This is minus sign. So they did it this way so that it will tally with this permanent magnet polarity. Because when you change the polarity, by, even though they make the signal here, so you can see this plus sign. So it means that if you want to connect the AVR terminal, first of all, this is positive, so you have to connect it this way. You can see this is the plus sign. So now when you plug it this way, you may have some issue which the generator may not give a current, because the generator produce light, like I've already described in my previous video. This permanent magnet here have to generate some amount of current before this AVR will pick up. This permanent magnet will generate some amount of voltage before AVR will pick up. So when you change the polarity, it will affect, because this permanent magnet here will be sensing south, while the rotomagnet will be sensing north. So there will be a lot of issue. So it's better when you want to do it, go for the light polarity. This is plus, this is minus, so that it will tally with this permanent magnet they put here. Though this one I would change it to neutral magnet, but I just want for you to understand. So now the input here is this is like one of the popular or common AVR. Some have a different wire, but this one is when you check the wire, it is 6 by number. So now this one is for the mains. This one is for volt trimmer. Some people will ask, what is volt trimmer? Okay, let me come again. Now, a lot of people can wind this generator. It is somehow simple to wind, but this one is very complicated. The reason is, look at this way. You can see Though slot here is left open, is left. They didn't. They leave it. They didn't open it. So, but if you check here, there is a wire configuration is different. This is the main pole 1, 2, 3, 4. You can see it. If you come over here, it is 1, 2, 3, 4. So now, okay, what's the difference now? What's the difference here now? The difference is they wind this way for battery, and no, this way for battery, and this way for exciter. If you come over here, you will see it. So now it has a lot of terminal output here. This one, this red and black, is for main output, 220 volt output. Then this thing wire here is for charging, battery charger. Like this one now is for battery charger. So this wire is for battery charger. Okay, when you come over this now, this one is for, this is for exciter. This is exciter, and this is a volt trimmer. This is exciter, this is volt trimmer. So now let me explain further. Volt trimmer is like when you are putting load on this generator, the voltage will be maintained to 220 volts. When you're putting load, or even when you are increasing the speed of the motor, the speed of your engine generator, the voltage will still maintain 220 volts. This is because of volt trimmer. So a lot of winder, when they wind the generator, they won't put or do the volt trimmer correctly, or by cutting one of the volt trimmer. So when you do that, this AVR is useless, because it is from this winding the monitor is like a sensor. This volt trimmer is like a sensor. This AVR used to monitor the input voltage that will goes to this armature here. So when you cut this volt trimmer, the generator will bring light, but when the engine speed is running higher, it will be giving you higher voltage. When the engine speed, when you put load, the voltage will be going down, because what this AVR does is that when you put load, it will correspond by adding more power, releasing more power to this load, so that the voltage will be maintained. So, but this capacitor based stator, when you put load, the voltage will decrease depending on the capacity of the load. The voltage will reduce because it doesn't have anything to monitor or to increase uh, uh, the the magnetism of this load. So it will be left like that. But this generator stator, when you put load with the help of this volt trimmer, you can see a big capacitor here which store voltage. So it will release some amount of voltage, and when you remove the load with this volt terminal, it will sense that there's not much load running on this drawing from this coil. It will reduce some amount of voltage going to this bulb, because assuming you didn't reduce it, you have a high voltage. Maybe you have something about 250 or 300 voltage. So maybe in my upcoming video, I'm gonna run the test live. I'm gonna do the video so that you guys will understand what I'm talking about. So the difference between induction generator or brushless generator and AVR generator. So this is how it works. The whole the secret is lie on volt trimmer. So that's why not all people can wind this AVR generator correctly. And when you got the AVR volt trimmer disconnected, expect high voltage when you hide the generator, or when you put load, the generator cannot respond again, because this is like a sensor. This is like a sensor wire. This is like a sensor wire. So it goes this way. You can see. Then this terminal goes to this brush here. that attached to this commutator. So it work hand in hand. It work hand in hand. So in my next video, I will I'm gonna run two generator. Maybe I will use my small generator, tiger generator, to do the experiment. Then I will use this one that has a VR to do the test, so that you will see the comparison, the difference. This induction or brushless generator, when you increase the speed, you expect high voltage. But this one, so far the AVR and voltmeter is connected correctly. When you're increasing the voltage, when you're increasing the speed of the engine, the voltage will be maintained. And when the voltage has dropped below, because there is no magic here, when the voltage has dropped below, we also have a low voltage. But when they did it so that when the speed is high, assuming you're running the generator on 4,000 RPM, the voltage will still be 220 volt. So they make it such a way so that there will be a stable output. There will be a stable output. So in my next upcoming video, I will do some um, recording live, so that you will see. I will hide the generator. I will hide the engine speed. Then I will hide my small induction brushless generator engine. You will see when you hide it, when you increase the engine speed, there will be a high output. Maybe goes up to 300 or thereabouts volt. But this generator, when you hide the speed, engine speed, the voltage will be maintained. The voltage will be maintained. So um I believe with my explanation you have understand. So, but I will back it up with a video so that we understand it very, very well about what I thought or what I'm talking about. So, like I already explained earlier, using a permanent magnet, running it, regulating the voltage is very, very uh, is where the issue lies. But uh, induction generator, you can increase the voltage, whereby assuming you put 20 UF and you got 150 volt. When you put 25 UF or 30 UF, maybe we got something about 200 volt or thereabout. So it can be manipulated. But using a permanent magnet, you can only increase the speed. You can only increase the voltage or decrease it by the speed. There's no any other way. So in my next video, I will show you uh, when you hide the engine speed of induction or brushless generator and the speed of AVR generator. Thank you for watching.